Okay, in this video we're going to look at an example that is related to transformations of graphs. So let's suppose that we know the point 5 minus 3 is a point on the graph y equals f of x. So what that tells us is that we have a graph, and if we go through this point 5 minus 3, we know the graph goes through this point. So another way to think about that is that f of 5 equals minus 3. And that's because every point on this graph is of the form x comma f of x. So that means this point right here must be of the form 5 comma f of 5. And so here we have that point right there. Okay, and the trick here is that we don't know anything about any of the other inputs of this function. All we know how to do is plug 5 into this function. That's it. So that means if we're plugging x minus 3 into this function, we need to have x minus 3 equals to 5. So in other words, that's how we're going to start off here. We're going to say x minus 3 has to be equal to 5 because that's the only thing we know how to plug into this function. But notice that's going to tell us that x equals 8. Okay? And now we can plug that into here, and we'll get y equals f of 8 minus 3 plus 2, but that's f of 5 plus 2. But notice, we know that if we plug 5 into this function, we get negative 3, so that's going to be negative 3 plus 2, which is negative 1. So notice we have an x value of 8 and a y value of negative 1, which tells us that 8 minus 1 is a point on this graph. Okay, so let's keep going. So we go over here and we want to find a point on this transformed graph. And so recall the only thing we know how to plug into f is 5. So that means negative x better be equal to 5 in order for us to make any sense of this. So that means we need negative x to be equal to 5, but that tells us that x equals negative 5. So that gives us the x coordinate on our graph. And now we'll plug that into this expression to find y. So we have y equals f of, so negative 5 into here will give us positive 5, plus 9 over 2. So we know f of 5 is negative 3, that's given. Good. So we have that. So negative 3 plus 9 is 6, over 2 is 3. So we have our x coordinate and our y coordinate, which tells us that our new point on this graph is 5 comma 3. Great. So now let's keep going. So we want to find a point on this transformed graph. So again, the only thing that we know how to plug into f is 5. So that means that 3x minus 1, which we're plugging into f, that better be 5 in order for us to get anywhere. So we need 3x minus 1 to be equal to 5. So that tells us that 3x equals 6, which tells us that x equals 2. So that gives us our x coordinate. Now we're going to plug that into this expression. So we get y equals 2, f of 3 times 2 minus 1 plus 4. So that gives us 2 times f of 5 plus 4. But then remember, f of 5 was equal to negative 3, that's given. So 2 times that is negative 6. So we get negative 6 plus 4, which equals negative 2. So that's our y value, negative 2. Put that together with our x value. That tells us that 2, negative 2 is a point on this graph. Okay, so we've got one more. So we want to look at this transformed graph, y equals f of 2 minus x plus 7. So again, the only thing we know how to plug into f is 5. So that means that 2 minus x must be equal to 5 for us to be able to make any sense of this. But that tells us that negative x equals 3. But that tells us that x equals negative 3. Okay? Plugging that in for x into this expression, we'll get y equals 2 minus negative 3 plus 7. So that's going to give us f of 5 plus 7. But again, we know f of 5 is equal to negative 3, so that's equal to negative 3 plus 7, which equals 4. So now we have our new x-coordinate and our new y-coordinate, which means that negative 3 comma 4 is a point on our new graph. Okay, so that's the end of the video.